In this video, you will understand the design and testing of a ring counter.
So let's see the design part with respect to truth table. So this is the circuit diagram. So let's see or verify for the truth table. So QA, QB, QC, QD are the outputs that we desire, and the input for these has to be given in A, B, C and D. So the first row are the input, which will be actually also seen in the output when the mode as pin number 1 is set to high. And the second row onwards can be observed by setting mode low and then switching on the clock pulse that you can observe in the verification on the kit. So here let me explain the statement that we discussed earlier. So the last QD is coming as input to the first flip-flop, so that is to A. So the input as we have designed here in the table, QA is 1, QB is 0, QC is 0 and QD is 0 in first row. So in second row under QA, the input of QD under first row would come and sit under QA, followed by as mentioned, under a clock pulse every register is being shifted. So thus QA data would come to QB's second row, QB's first row data would come to QC's second row, QC first row's data would come to QD's second row, and QD's first row data would come to QA's second row, and so on. It happens as and when we press the clock pulse, but you have to make sure that the mode is low. So mode should be high only when you are giving the data or getting the output for the first row. So similarly, you can also verify for a different truth table. You can see QA is 1, QB is 0, QC is 1 and QD is 0 for the first row. So as and when we set the mode to high and press the clock pulse, these are the input that one must set at pin number 2, 3, 4 and 5. Later on, to see your second row data, the mode should be kept low and a clock pulse has to be pressed. Then QD data would be appearing under QA and QA data would be appearing under QB and so on. So this is how you can verify the truth table for different truth tables that you can write. So let's see the circuit connection for the 16-pin IC. These are the inputs A, B, C, D, M, the mode that must be connected, high for transferring the data for the first time, and low to shift the data by one register. Clock pulse, QA, QB, QC, QD are the outputs. 7495 is the IC, which is a 14-pin IC. So you can see the last two, that is pin number 8 and pin number 9 and the 16 pin have been neglected here. So pin number 8 and 9 have been short circuited. From there it's given to a clock pulse, and pin number 6 is given to mode M, this is for your input, and pin number 5 is given to D, subsequently to C, B and A respectively for pin number 5, 4, 3 and 2. Pin number 10 is given to output QD as well as your serial output port 1, and then pin number 11 is given as output for QC, pin number 12 is given as for output for QB, pin number 13 for QA, and 7 to ground, 14 to VCC. So this is your circuit connection that one has to carry out.
So in this video, we'll be understanding how do we test for the ring counter and followed by Johnson counter using IC 7495, which is a 14-pin IC. So here are the 4 input ports which we have to give, and this is being the mode of operation. So when the mode is high, whatever are the inputs will be transferred parallelly, and the mode is maintained low, it will shift by every register. Okay, let's see how do we do that. And this is pin number 9 and 10 which are connected together to a clock pulse. This is pin number 6 be connected to mode. So as per the truth table, so let us give the input. So before that, let us switch on the kit. Now you get some random data, need not to be worried. So as per the truth table, QA, QB, QC, QD. So this is QA followed by QB, QC, QD, right? So this is again for input A, B, C and D. So input has to be given only once. The first row, for the first row, as you can see, the desired output is QA is high, rest all are low. So thus give QA as high, give set mode to high, that is pin number 6, and then you can see we have some junk value. As you give the clock pulse, whatever is the input is being transferred to your output, and then turn off the mode, and then as a press the clock pulse, it will shift by every register. So one clock pulse, it will shift the every register, that is QD data will come to QA, QA data would go to QB, QB data would go to QC, QC data would go to QD. Okay, so once I press the clock pulse, I should have the result. What result should I have? So this 0 should come here, this 1 would come here, this 0 would come here, this 0 would come here. Okay, let's see that. Okay, and second row, this is for the second row. Third row, what happens? It will again shift by one register. So this data would come here, this data would come here, and this data, which is actually 0, would come here. So this 0 comes here, this 1 comes here, this 0 comes here, and this 0 goes to QA after the third clock pulse. And similarly, for the next clock pulse, it again shifts, and so on. So now what we can do at any given point of time, you can change your input and verify the truth table. So let me take another example here. So now what we do is we'll change the input, as you can see in the video towards your right side. Let us give 1 0 1 0. You can see my output has not changed because I have to set my mode to high and then give a clock pulse. So whatever is my input is being transferred parallelly to my output. And now to shift the register, what you can do is make the mode low. So you can see the data is not changed. So as I shift, as I give the mono pulse, what happens? So this data would come here, that is QD would come to QA, QA would go to QB, QB would go to QC, and QC would go to QD. So I'll have the data as this 0 comes here 0, 1, 0, 1 after one clock pulse. And then next clock pulse, what happens? After I give a clock pulse, my data would be 1, 0, 1, 0, and then so on. So this is how you can realize. You can write the truth table first. Write the truth table, design for the truth table, and then accordingly set the input by keeping mode high. Then after you have set the input, give the clock pulse. Your input has been transferred parallel to the output, and then keep the mode low, and then press the clock pulse so that your register is shifted for every clock pulse.
Please do subscribe the channel to enhance your knowledge further.